Okay, so today we started two-step algebra equations, and when you're doing two-step equations, you just need to follow the rules that we did last time with one small addition. So the new part that you do when you're talking about isolating the variable is this part right here, that you make sure that you get rid of the addition and subtraction first. So in your equation, when you have a two-step equation with something like 2x plus 4 equals 10, the addition and subtraction would be right here. That's the first thing you're going to try to isolate away from the x. So we know we have to isolate the variable, but highlight, circle, bold, do whatever you need to do, because the only hard part about this is remembering to get rid of the addition and subtraction first in isolating, and then you're good to go. So we didn't do anything to the 2x, it's going to stay there, but in order to get rid of plus 4, we have to subtract 4 from both sides. So we'll subtract 4 from there, and we'll subtract 4 from there. So 4 minus 4 is gone. So we have 2x now equals 6. Now we're back to a one-step equation, and that's simply 2 times x. In order to get rid of multiplication, we do division. We show it this way as a fraction, because remember fractions are just division. 2 divided by 2 is 1, which just leaves you as 1x. And 6 divided by 2 is 3. And that's our answer. But we have to check using left side and right side. So our left side and right side, and the original part of our equation is 2x plus 4. And over here it's 10. And we're going to substitute the answer. So we're on this step now. Check your answer by using the original equation and substituting the answer in. So we have to take that 3 and put it wherever we see an x. As you notice, I put brackets around it because that's how I show substitution. This is really the distributive property, or straight up multiplication. 2 times 3 is 6, plus 4, it's 10. 10 equals 10. I know that question is right. So that's basically it, but I want to show you a bunch of different things that you're going to see with it. So the first is you could have negatives and even decimals if you wanted. So let's go something like negative 2.5 m plus 5 equals something like 15. So remember that the only new part of this is that we have to get rid of the addition subtraction first. We have to isolate getting rid of that part. So we have minus 2.5 m. We're not going to change that around at all. We're going to add that 5. That's the question. We're going to subtract 5 away to make it gone from the left-hand side. Remember, you have to do the same thing to both sides. So I subtracted, or I added, sorry, let me go back. This one here is subtraction. So I subtracted it to get away from there. So I have to subtract it to get away from there. Over here we have negative 2.5 m. 5 minus 5 is gone, so it's 0. And that equals 10. Even though this is a negative decimal number, we are still looking at the operation of multiplication. It's negative 2.5 times m. In order to get rid of it, we're going to divide both sides by the same term. Don't forget your negative sign. Anyhow, that crosses out, and that will only leave m. Let me get me some room here. And m is equal to 10 divided by negative 2.5, which would be negative 4. Now to check and see if we have that right. We use our left side and our right-hand side. The original was negative 2.5 m plus 5. And the original right-hand side was 15. So this is negative 2.5 times negative 4 plus 5. And that is 10 plus 5. Negative 2.5 times negative 4 is 10. And then you add 5. So here we have 15. That equals to my right side. So this answer is correct. So what else can we do? We can put negatives. We can put decimal numbers in. Well, what about that distributive property we were talking about? The question might start off with something like this. Now, before you get started, remember Ross arrows, if we take what I named them after myself, or just the distributive property, we have to multiply that through before we even begin the question. 3 times y multiplying that in is 3y. 3 times 6 is 18. So once you see that, once you do the distributive property there, well, all you're truly doing now is a two-step algebra problem, which we've already done 2 of, and we did a whole bunch of practice in class today. Remember, the whole trick to this is up here is do the addition subtraction first, so I got to get rid of plus 18. 3y plus 18 minus 18, because that's the only way to get rid of that, equals 24 minus 18. 18 minus 18 is 0. I have 3y equals 6. But I want y by itself. I have to isolate the variable all by itself, so I just need y. We see that that is multiplication, or should recognize it's multiplication. And the only way to get rid of multiplication is do the opposite, so we're going to divide that by 3 and divide that by 3. 3 divided by 3 is 1, and that's why we have 1y right there. And 6 divided by 3 is 2, and there's our answer. But now we're going to go back into our original equation, and now our checks are going to be just a little more complicated, but nothing outside of what we know how to do. So when we do it this way, we have 3, another set of brackets to show substitution, and 6. And we know we have to do inside the brackets for our order of operations. So we have 8, and that's 3 times 8, and 3 times 8 is 24. Left side equals right side, and we're off to the races again. I hope you're seeing that all of these are just the same type of questions with just a little subtle difference. So check out this subtle difference. What if we had something like 5x plus 10 minus 3x equals negative 20 minus 6. Let's throw some integers in there. Well, I hope you recognize before you get too into this that there are multiple x's, there's multiple numbers, and we have to go back and do that idea of collecting like terms that we did last week. So if we're collecting like terms, we can collect the x's together, and we got 5x minus 3x, so that will give us 2x and 10 on this side. Over on the right-hand side, we have minus 20 minus 6. Think about it. It's minus 20, you take 6 more away, so that's going to give you negative 26. Once we're started now, we know we got to get rid of the addition and subtraction first. We have 2x plus 10 minus 10 equals negative 26 minus 10. They are gone. We have 2x is equal to negative 36. But I don't want to know what 2x equals. I want to know what 1x equals. So we have to get rid of this 2. It's multiplication. The 2 beside the x so close is showing multiplication. It's 2 times x. It's 2x. So we have to do the opposite, which is division. We have to divide both sides by 2 in order to get it gone. 2 divided by 2 is simply 1x. And negative 36 divided by positive 2 is a negative divided by a positive. We know from our integer rules that that is going to be a negative answer, and that will be minus 18. Circle it. You'll need to come back to it later. And your check is a little bit bigger, but just because it's a little bit different doesn't make it bad. 5x plus 10 minus 5x minus 10 plus 10 minus 3x. That's my left side. And my right side was negative 20 minus 6. So over here, we're going to show substitution by putting that number in. Then we're going to add 10. Then we're going to subtract 3 times negative 18. And on the right-hand side, we might as well do it, and we know that negative 20 minus 6 is negative 26. So we have to do this left-hand side to make sure it comes out to that as well. So 5 times negative 18, I've got to break that up. 5 times 10 is 50. 5 times 8 is 40, so that's negative 90. Plus 10, and we have negative 3 times negative 18 is positive 48. And now we add that all together. We have negative 90 plus 10 is negative 80. Negative 80 plus 48. That doesn't sound right. Let me check my math up here. 3 times, oh, that's going to be 44. Let me just move that right there. It's okay to make some mental errors, but as I was looking at it, I knew that wasn't going to come out. Anyhow, we have negative 90 plus 10 is negative 80, and negative 80 plus 44 is negative 26. So that side equals that side. And you can see that the questions are starting to get a bit bigger, but it's just more of the concepts that we've already done in class. So when you're looking at it, yeah, that's a fair bit of math work to do. And there are many different concepts starting to be added into it. And that's why we talked about these layering of concepts and the spiraling of the math, because it's going to keep coming back and keep coming back and keep coming back. You have to ask when you're not sure of one concept, because you're sure to see it in another. And as they start to get bigger, you're going to make some smaller mistakes, and then you're going to get frustrated with your math. So anyhow, keep practicing. This is not a one-day thing. We're going to look at this, and as soon as we're done with this, we're going to apply everything we've learned to formulas for area and volume and whatnot, because truly formulas are just algebra. They have letters that we substitute numbers into, but what more important is we're going to learn how to work backwards through all our formulas, which again is an algebra concept, because we're just going to isolate for the variable. So as long as you see that connection, that's what we're doing this week in math. Good luck.